Hello and welcome to the Decode Podcast. This is Rev 1.7. Thank you for joining us. My name is Daniel Stanfill from Aurora Boardworks.
And I am Elias Malfavon with Metal Etch Services.
And I am Elias Malfavon with Elemental Etch Services. And I'm Sean
All
Kincaid.
right.
I'm Sean Kincaid with K&F Electronics.
Sean Kincaid with K&F Electronics.
Okay, as you can see, this is a super professional podcast. Our first topic of this one is stencil defects. So I'm not even 100% privy to the first topic of the day. So this is, I guess, a private project you two worked on that I wasn't good enough to be involved in or something. Usually we discuss these things as a group, and especially if we're going to be doing it on the podcast, we're usually all aware of what we're going to talk about. So I'm going to get to enjoy this one along with the listening audience. Fill me in. What are we talking about?
It was more of, wasn't a project we were working on. So I ordered a stencil and I started printing on it, and the SBI kept flagging this pad for no paste. And I'm like, what is going on? So, sometimes you think maybe your first couple passes, right? Maybe the bead wasn't good enough. So I probably printed 2 or 3 boards, and then I started looking at the stencil, and I noticed one of the legs of the ICs wasn't cut out. So I called Elias just to get his opinion on it, and I heard it was called a Chad. And I took a photo of it. You could see it. It's got still got like the stencil in it,
like a hanging Chad from elections back in the day.
I don't know what.
That's exactly where that term came from. And just I'll let you continue, but an important distinction is that this is not a stencil that Metal Etch Services made. Continue. Had to get that in there.
But it is a lesser price, so I have to get.
Do you want all the pads or not?
Yeah, I guess.
It looks like you get what you pay for.
Well, here's the thing. It popped out, though, right? So we got it to pop out. But, I've had this happen once before.
Another question, Sean. You've talked before about a product you had where you used some sort of contact paper and you would actually knead the paste back and forth before you ran your first board.
Yes.
Are you still doing that, or did you not do that on this one?
Not on this one, no. Because I didn't run this job and I haven't put it into the system process that we have going on. I just did this. That was more on that job of the 01005 pads.
Yeah. Where it's critical.
This thing is giant. There's nothing small on this. I mean, you could probably print this thing with a 6mm and be fine. But yeah, it was weird. You can see the edge of where the laser cut it, but it didn't cut it out. I don't even know. And then so I called Elias about it, and then we talked about, he called it something else besides a Chad too, but I was told it's called a Chad. And then I don't know, Elias, you can take it over from here, because that's about as far as I just know about the problem, right? I don't know the root cause.
And we could probably throw a picture of this up on the video, right?
Yeah.
In post.
Yeah. So, there's a few things that could go wrong with stencil, right? Missing aperture is probably among the worst of them, because if you're missing an aperture, it can basically render the stencil useless. So why did it happen? What happened? So you kind of explained, you can see the laser path is actually what you're looking at. So in order for the laser to penetrate and cut through the foil, there has to be certain things in place: appropriate power settings, appropriate motion speed. Focus is paramount. So the distance between the lens of the laser and the substrate that it's cutting, in this case stainless steel. So if that focus relationship is out of whack, then you can end up not actually cutting. And in past times, that's how fiducials were marked. The laser would have a motorized beam expander, so it would take the same cutting parameters or similar cutting parameters, and then the motorized beam expander would take the lens out of focus so that the laser was so weak that it wouldn't actually penetrate the metal, but it would still make a marking. So essentially, if the laser is out of focus, that's what's happening. It's just scribing or mark the surface, but not actually getting through it. That can happen for a few different reasons. There's some consumables at play within the laser system itself, like a cutting nozzle. There's a lens or protective glass that goes in between the lens and the exit of the nozzle. If that becomes clouded or dirty or dusty, then it dilutes the power of the laser or diverts the beam. There's also the potential that the laser beam could be contacting the orifice that it goes through. Any of these things can weaken the beam or redirect the beam or defocus the beam, and it'll end up in a situation like what Sean saw. So the possibility is there, especially if the circumstances of cutting aren't optimal. So because of that, there's systems designed for stencil QC, right? How can you verify or validate that every aperture that's supposed to be on the stencil is actually there? Some of these are onboard. Some of the new laser systems have onboard inspection and various different ways of doing that. And then there's offline options as well. ScanCAD is the name of a company that has a system that's been around for quite some time. Takes an actual scan of the stencil and then compares it to the Gerber data, checking to see if
offline's going to be far superior as far as like volume production, right? Because if you're doing the inspection portion of it with your laser also, then that's just more time. It's not cutting, right?
Sure. And there's a couple different techniques of inspecting or monitoring during the cutting process. For instance, we use LPKF laser systems, and on the G6080, they have what's called real-time process control. So when an aperture is missed, there's a certain signature you can imagine, like a reflection, and there's a sensor that detects that signature, and it will flag it. And at the end of the profile, the laser's camera system will jump to that point so that the operator can verify if it's been cut or not. The useful thing about having it on board is if there is an issue, then you can tell the laser, okay, recut, and it'll go and correct at that moment. But there is some concern about the tool verifying the tool, right? If your inspection is embedded within the laser system. So an offline inspection technique is desirable, and then it generates reporting and so on and so forth. Now, some other stencil laser systems, for instance, Tanlin is another that's out there, at a camera-based inspection on board, and in that case, you're correct, it would slow down, maybe not significantly, but it would slow down the cutting process as it verified in real time as well.
My question is, why does it always happen on one pad?
Not sure that it always happens on one pad, or that the ones that make it to you are only one pad, right? Because if there's many, then it's kind of obvious, right? I can't speak for the organization that made your stencil or what their inspection process was, but if it was visual based, if it was just, an operator kind of looking at it, you can imagine that it would be not that hard to miss that there was one opening missing within thousands, as opposed to if there was some kind of catastrophic failure and there was many missing. Another thing that can lead to this kind of defect, if you imagine during the cutting process, these chads, right, to use that term, or apertures, the actual area that's cut out, where does that go, right? So most modern laser systems are pretty open. Used to be there was an extraction cut directly under where the apertures were being cut, and it would pull that aperture away directly. But with the gantry systems that are common these days, it's very open. So a lot of the times, the apertures will blow down through the bottom side. There's kind of a screen down there, and there is exhaust, and they'll get carried away. But what can happen is that the aperture will stay on the top side of the stencil and just kind of bounce around as the cutting occurs. And if it ends up in the path of another aperture to be cut, Now you're trying to cut through, say, 8 mils of steel rather than the 4 that you anticipated. And that can also cause this type of defect, or it can actually, for lack of a better description, weld that other aperture onto the surface of the stencil too. So that's another how this could happen.
Because I've had it with actually 2 different stencil manufacturers, and both times it was literally just one pad on both of them. The first time I didn't have an SPI, so I didn't catch it until we ran probably a couple hundred of them, and we noticed during an inspection I didn't even have an AOI back then, so we were visually inspecting everything, and then we noticed, oh my God, C23 on every single board, the left pad's not soldered. And then we looked at the stencil and seen that it wasn't cut out. That one was more defined as far as the square box around it. It was really weird. But, at that point we had ran the entire job through the pick and place line. But this one, with the SPI, I caught it before it even got populated. So, but it was just weird. It's both times it's been one pad only.
Yeah, I think more oftentimes than not, it comes down to a focus issue. And if you imagine, you're a kid and you got a magnifying glass, right? And you're using the sun to torch the ants, and you got to get that magnifying glass at the sweet spot, and then ant carnage occurs. It's kind of the same thing with the laser, right? There's a lens and there's a focus point to that, and when the laser is in focus and concentrated, it's going to do its job. And the relationship between the stencil surface, the foil you're cutting, and that lens is critical. So there could be a myriad of reasons why it becomes out of focus. If the surface of the foil is wavy for any reason, right? If it doesn't have good tension to it within the frame, then you could be in focus at one spot and not in another, right? And that could explain missing it in a certain area. So our laser systems, for example, they have a laser height sensor. So before each stencil is cut, there's a value within the software of the distance between the focus height, right? So that's the distance between the laser and the actual metal. So the laser system goes out into 4 corners, all 4 corners of the foil, and then in the middle, and measures the value, the height value, and it can actually adjust independently to make sure that not only is the center in focus, but all 4 corners of the stencil are in focus as well, so that you maintain that focus point throughout the entirety of the stencil.
Does that do that with like a fiducial in the corners, or how does it know, or is it XY
No,
based?
How does it know the height?
No, that this is the upper left corner, this is the lower right corner. How would it?
Oh, XY. Yeah.
Yeah.
How many different materials have you cut with on your lasers?
Stainless steel is obviously the lion's share of the stencils we're making. Nickel, we've cut nickel on there. Invar, Kovar, different grades of stainless.
Does that play a big factor as to intensity and power and all those kind of things and focus and everything? I mean, does the alloy you're using?
Yeah, that's a good question because, for instance, nickel is going to be much harder than stainless steel, and also reflective, right? So it has different properties to it. And then even within a certain metal type, are you going to use the same tool set to cut an 8 mil stencil as you will a 4 mil stencil? The answer is no. So if you have laser parameters per metal type and per thickness.
And what's the maximum thickness that you can work through?
1 millimeter.
With accuracy. 1 millimeter?
1 millimeter. Yeah, and there's some limitations there, right? You're not going to cut 0.1 millimeter holes into 1 millimeter, but yeah, we can go up to 1 millimeter with our systems.
I'm satisfied. Elias, you always leave me satisfied.
Always look satisfied.
How often? I mean, have you actually done stencils that were almost 40 mils thick?
Not for the application that you'd be thinking of, right? Not for printing solder paste. With maybe a caveat or two. So not that you're printing 40 mils worth of paste, but if you had something crazy that you were trying to clear on a board, you might start with a 40 mil thick foil and then mill up clearance. But I think for actual paste printing, generally, I wouldn't see anything past 10 mils.
10 mils. That's still, those are some monster deposits.
Yeah, like shielding, or it's got to be kind of a real specific purpose why you'd need that. You're not going to be printing your ICs at 10 mils thick, right?
This happened probably in your facility too, every now and then, right? This isn't just like a.
Yeah, it's exceedingly rare with the laser systems that we have currently. In previous years and with different systems, it would be something that could be encountered more frequently. But it's
That's kind of like missing components. Sean, have you ever had a populated board that the machine didn't know, like that there was a part completely missing, but the machine thought it had finished the board?
Yeah, and the problem with that I've noticed too is it usually gets some of the paste on the nozzle too, so then now I got to clean all my nozzles afterwards.
I don't know that we've had that happen yet.
The worst is when it thinks it placed it and then it places another one, or it didn't place it and then places another one on top. Have you had problems? Started with the old Eco, right? Which is your old 30, I don't know, really old machine.
No, I mean, I've definitely had those things happen with my older machines, not the platform I'm running now, but yeah, our older, all kinds of things would happen, like
Yeah.
inexplicable things.
Usually it's when it's like a instead of using the optical sensor, it was using the pressure sensor. For me, that's when I would notice it. Yeah. Or if like
On the Eco, you're saying?
yeah, especially if I didn't like digitize a Z height and I just left it at a standard, and it was like a really thick cap, and I said it was like just a regular 1206 height, but it was maybe double triple that, like it would slam it down and then maybe not register when it picked it up, stuff like that. But I don't know if I've seen it much on the new machine. I haven't ran it as much as I ran the old machine.
That must have been similar to my data's old machines. Like their newer ones aren't like this; they're way more advanced, But their super old ones they had would have both optical and mechanical alignment. So a lot of them would have mechanical centering, it was called, and it would measure components at different heights within the jaws, and the thing was those jaws actually had the electrodes on them for testing too. So like while it did its centering and everything, it could also do its electrical verification stuff. So it could actually do some stuff like that super fast without even really affecting cycle time. But it would also kind of cause a bunch of problems other ways. And yeah, lots of headaches with different old equipment for sure.
Yeah.
So the next kind of topic we had to go over is a component that I was working with on assembly we had here, and the package name, or the part name for anyone that wants to look it up, is a AP63356Q, and that is a VDFN 3020-13 SWP package with wettable flanks. Obviously,
Bingo.
Everybody knows all of that. I don't even like, it's super redundant to even say any of that. But this component was pretty cool because it had like kind of a standard looking DFN start to the bottom half of it, where it's just got leads on both sides underneath, and then it's got some larger thermal pads on the top half with a little narrow strip in the center. We'll put the picture up, so it's not like I have to paint such a perfect picture with my words here, but the side solderable area, there's certain applications I found out when I was reading up on the data sheet and based on, helpful suggestions from people on LinkedIn. And there's like automotive applications for this component that actually requires 100% fillets all the way up the side on, the perfect terminations all the way around the whole thing. And this was kind of a big point of focus when I was working on this stencil with Elias was, what are we going to do on this component? This is one of your non-standard packages that's not just kind of straightforward. And especially feel that way after putting this on LinkedIn and hearing everyone's, different opinion on the right approach. But I guess first, before going too much further, Elias, do you want to share what your thoughts were on the strategy and what might work best?
Yeah, this was one of those fun ones. I think we had kind of a lengthy call about it and kind of bounced some ideas off each other and being able to look at the component itself, diving into the data sheet to see if the manufacturer had anything in terms of a recommended solder footprint, which that would be too easy. So
Yeah, they had no suggestions,
yeah, so I think what was most interesting to me were those what did you call them? Wettable flanks?
That's right. Everyone knows that.
Yeah, okay. It was interesting because not only did it jut up the side of the component, but there was an angle there as well, right? So it kind of
Yeah, there's an extra profile. It isn't just a solid edge. There's like a slight shelf that it has to kind of make it up to. It's a strange looking footprint.
right. So I think our thinking was we need to feed that solder, but we can't print solder directly underneath that, right? Because it's along the component body. So like we added a bit more width to the aperture than we would typically. So if memory serves that there's like 18 mil pitch on that. So kind of using the half pitch rule, we would be 9 mils in aperture width. We went a mil over that. We went with a 10 mil wide aperture. And then kind of the same type deal for those. I don't know, is thermal even a good description for those larger pads?
I I thought so. If as you're talking here, I'll look up. Alex Norman had a good breakdown of um, what the package actually is, like what the internal construction of the component is and why it has those pads.
Yeah, he spit some knowledge there, didn't he? Yeah, so looking at that area, it was same type of effect. Even in that center pad, there was wettable area along the component body side. So that center pad, we wanted to make sure extended out to the end of the land so that there'd be opportunity for the paste to climb up there and create that nice fillet that you described. Um, so yeah, I felt like we had a solid approach. And then you made your LinkedIn post. And the peanut gallery came out with all kind of different suggestions and concerns. And you start reading these things and you start thinking, well, did we go with the best technique? And I think that's kind of where we both stopped and said, there's more than one way to skin a cat here, because there were so many different ideas and so many different opinions from learned folk, and a lot of them made sense, some of them didn't, but I think that was kind of the beauty of it, and always fun to see the ideas people have.
Yeah, people had plenty of different suggestions, and Alex said the reason for the odd shape is that the lower half with 6 pins is the control section, and the top section with the large pads is the power section that contains the switching FETs. So, I mean, he didn't exactly say thermal, but I mean, that's going to be the reason for the larger pads. The power section with the switching back, like that's going to be where the heat is, and the heat dissipation is going to need to spread across those larger pads. I think is how that works anyway.
Yeah. So what were some of the concerns or suggestions or recommendations or opinions that you saw in your post?
Well, one person thought that we definitely were going too wide on our strategy. They thought we needed to make much thinner deposits. Maybe one of them I saw was thinner and longer. So instead of kind of to the edges in the X, they went narrower in the X and longer in the Y. And they also did do something that I don't think necessarily would have been a bad thing. They had this offset on the larger pads where the paste wasn't centered on the larger pads, but was kind of offset towards the edges of the component. And that I think would have been a sound strategy that would have worked fine. We didn't do that, and it also worked fine. Everyone was so concerned with bridging. At least a handful of people said, that they were worried that we'd experience bridging with our strategy. And we got x-rays of everything, and we'll show the x-ray because they all came out clean as a whistle on that part. So no complaints there. The strategy worked great, and I'll make another updated post that will highlight the success that Metal Etch provided for us here.
Did you window paint any of those? Because they were pretty large. I mean, I don't know. You're looking at a data sheet, right, or a picture that you were showing, and the pads look kind of big. I know they were like T-shaped though, kind of, right?
We didn't window paint it. They're not that big.
No.
Yeah, they're kind of small for a window pane approach. But
I've seen the X-ray now, so I agree with it. But is the window pane like only necessary on these larger like D-packs and stuff like that, or would it help with gassing with anything?
well, I think necessary and possible are two different things, right? You have to have a certain amount of real estate in order to deploy that technique. So imagine on the low end, you're going to have 8 mil wide ties. So imagine 4 8 mil wide ties. How big does a pad need to have in order, or aperture need to be in order to accommodate that? And there's some different techniques. You could do a single stripe. Yeah, it's not always even possible.
How big does your starting aperture need to be before you want to divide it up?
Yeah, these things were not very big. I don't have the dimensions available for those outside pads here, but they certainly
for
were.
example, an 0805, like something that small, if you were going to try to crosshatch or window pane that, now you're not going to have the right area anymore. You won't have sufficient paste because you've taken away too much volume by doing the hatch.
Yeah, I think that was one thing that was a bit interesting reading through the replies to your posts. Some people had the opinion that, the leads are too wide or whatever the case is. Correct me if I'm wrong, but all you posted was a picture. So nobody had access to the dimension of the pads and the pitch.
Right. Making lots of assumptions.
Yeah, I mean, looking at a picture online, everything is blown up, right? So I was looking at it and I was like, those things look huge.
Yeah, I believe they were 24 mils by 51 mils. That's what comes to my mind. Those two outers. So not much room for hatching there. Suppose you could have striped them into two. The X-ray doesn't lie. Looks beautiful.
Yeah, I wouldn't change a thing after looking at that.
Yeah, I think that's what makes the stakes a little higher, right? It was a bottom terminated component. And that was, I think, one of the first questions I asked Daniel, like, is this going to get X-rayed?
Is that board flowed twice or once?
The board was flowed twice, but this was on the top side, only reflowed once.
Okay. I read somewhere that the more you reflow, the more your chances are for voids. So I wonder if you reflowed that twice, what would happen to something like that,
I could see that. I don't have any experience knowing that. And man, whenever we do a new job like this and we take the boards to get them x-rayed, it just, as soon as I get the images and look at them, it just makes me wish we had one so
Right?
bad. I would
Right?
be playing with that thing all the
All
So
day
cool.
time.
long. All day
And I
long.
would learn so much
Right.
about reflowing and
Yeah.
just, oh man, everything, the solder strategy, the paste strategy, the stencil design, all of it. Like that would really accelerate learning and develop, research and development and all of that. But, I take what I can get. Anytime we get the feedback and the images, you learn what you can from them. And fortunately, we've been getting to do quite a few new jobs recently. So it's been cool to get to see some of these images, but sure does make me wish we had one. I'm sure you're the same, Sean.
Without a doubt. I seen that picture and I'm
Yeah.
like, oh my God, I need this thing. But did you have to create a new package for that, or was that loaded already in the
Oh,
library?
yeah.
Yeah.
Oh, yeah. No, I had to create a new package. And what I ended up doing was I did that flip chip strategy. And actually, I did two. I taught two ways. One was at odds, so that's not going to make sense to anyone else but us,
The best
that
feature on
that
EuroPlacer
odds.
for hard to place or hard to teach.
It just took an image of those
Yeah.
pads and like it was weird looking image, but it lines up perfect on the board and it placed it perfect,
Yeah.
But I also did it just in case, and it tested fine both ways, where um I taught it the six leads, the two rows of threes, I taught it what those shapes were in a flip chip package. So I got it to extreme high confidence on those rectangles. And then I taught it that narrow strip in the center because that like was kind of essentially a polarity indicator.
Yes.
If that center stripe was lined up, then you knew it was the right orientation.
Right.
So uh, it was pretty easy either way to teach a package that was going to be super identifiable and confident that it would place it the right orientation.
That'd be an awesome video to see, man, to just show people behind the scenes of when you get a new odd package like this, what it's really required to program in place, because it's going to be placed a whole bunch of times. So you don't want to be stopping and you don't want to be hand placing a whole bunch of stuff. So there's a lot of effort required. And when you get it to say those beautiful words of test okay, and after you keep hitting analyze and you keep seeing test okay, the fulfillment you get from it is just it's rewarding,
We did a prototype run this last week that was only 5 boards total, and the pressure was really on, because it's like you just have such a limited opportunity to get it right. And they actually wanted to come through the facility and be there when we were running it. So we ran one board ahead of time just to try to make sure, that we weren't going to fall on our face in
Right.
front of them when they showed up. And man, I put a lot of work, into it on the front end, really checking. It's not like I had to put every 0402 capacitor under the camera or whatever, but anything non-standard like this buck converter, like I put every single one of them underneath the camera and either, found the right package or created one. And it made all the difference in the world. I mean, the thing ran so smooth. It was such a privilege to be able to watch it go through the first time and have like no picking errors. It just, hummed right along. Probably double-sided assembly, a couple hundred unique components, and at least over 100. It was like probably 110 unique component part numbers, and hundreds of placements per side. And it probably had a total of like 30 minutes runtime, for both sides all in, for a brand new job first time. So I was pretty happy with that.
Yeah, I don't think people understand how hard it is to run your first job and you just see a waiting PCB, right? You don't see any. That is like the most beautiful screen. So when I'm walking through the shop, I'm always looking at that screen saying, making sure all I see is a waiting PCB, because then I know it's running flawless.
How many errors are up on that
Yeah.
screen, or is it running good? Okay, well, the next thing is probably going to be questions from the audience. We've got some listeners submitted questions. So, Elias, can you take us through some of our questions that we've got prepared?
Yeah, we're happy to get back to this segment after a few episodes with live guests. But first up, we have Mr. Mike Wang, who's a supporter of the cast. And without further ado, here's his question.
Here is my question. How should we get more interesting topics in LinkedIn and then get more interaction with the customers?
I love this question from Mike because it kind of ties into what Mike Conrad was talking about educational based posts these days, right? That's kind of like what drove me to LinkedIn. Is I started learning from all these experts and stuff like that. And I think the more educational you have it, the more fun it is, the more you're going to get engagement from the people,
It's a good answer. The thing about his question that's actually striking me is that he said get more interaction with the customers. And that's a really good question, because that's kind of the actual goal of what we're doing on there, right? We want to engage with the customers, with the potential customers, and drive revenue to our business, ideally. And certainly learning, being a process engineer, I've learned a ton being on LinkedIn. We've talked about that before. The interaction that I get is mostly with other people in the field, right? Other people in the industry who do this as a job also, who either design the products that we build or also build the same type of products that we build, get a lot of good discussion and engagement from those types of people on what we're doing. I mean, especially because the posts that I'm doing are purely process related, right? So I'm outlining the nitty gritty technical aspects of the job and what we do. So the people who are responding to that are the people who understand that and get it, right? So maybe I'm missing the mark, and maybe there's really not a way for customers to engage with the type of post or content that I'm providing. It's definitely an interesting idea. Elias, do you have any interaction with your customers through the posts that you're doing on LinkedIn?
I'll see customers react in terms of, the thumbs up or a light bulb or something like that. But I would say it's not all that often that I have direct engagement with them. I think Mike's question kind of dives into the question we ask ourselves every time we go to post something, right? Like, what can I post that is going to get interaction at all, right? Because you can make a killer post, and if nobody ever sees it or interacts with it, didn't really land. And I also think even if your customers or prospects aren't directly engaging in a certain post, doesn't mean they're not seeing it, right? Doesn't mean they're not spectators to it or consuming it and without direct interaction. So, but it's tough because informative posts are fantastic. It's too dry and it's just a presentation of facts. People don't tend to really pay too close of attention to those, rather than if you create a post that gives the opportunity for somebody to give their opinion or their thoughts or their recommendations. Those are the ones that seem to blow up.
Yeah, or if you start out with a false premise based out of, incompetence or ignorance, those do really well too.
Yeah, like just saying that, jet printers are completely going to replace stencils in the next 15 minutes.
He said they're superior
in every way.
I don't know who you guys are talking about, but he sounds brilliant.
All right, that was a good question. Got another one this week from Caleb Chenoweth. Did I say that right? I hope I did.
You did, and he's going to be a guest coming up soon, so that's exciting.
All right, Decode. A little bit of a two-parter here, but moving beyond the current buzz around AI, what innovative technologies or advancements in manufacturing are you most excited about? And how do you think these developments will shape the future of our industry?
For me, his answer for Caleb is, so there's a company I had come by recently they sell these robotic through hole. It's not where you actually, the components are placed automatically. What it does is have you seen this Daniel from Robotas?
Nope.
It's so it'll take an actual picture of the board. You'll program which part goes on where, reference designator wise. And then it actually draws an LED path. And so what happens is a turnstile comes out of that resistor that you need to place. You pick the resistor out of there, and then it shows you on an LED light on the board of where to actually place the board, or place the part. And then once you do that, you click a foot pedal, and then it moves on to the next one. And then so you can just keep going. And if there's polarity, like in a diode or something, it shows you on an arrow pointing this way with an LED that's flashing on the board of what direction to put that part.
A nice Poka-yoke solution.
Yeah, for populating a through hole board. And to me that's wild, right? Because you could have anyone without any real knowledge of what they're actually placing come in and do that, but you could have a skilled operator really streamline and be as efficient as possible in loading those components. That's not really AI based, but just having that user function of user friendly and talk about also controlling somebody placing the wrong component in the wrong spot. It's not possible. There's a light on the board. I mean, obviously people can do people things, but there's a light on the board. The only drawer that's open is the part that you're going to use. Place next part, place next part. To me, it really opened my eyes to what's available for the future to come.
I think my answer to Caleb's question would be the evolution of technologies related to the circuit board fabrication. Like, they are getting to the point where, like, I went to Apex at the start of the year and saw Nano Dimensions Dragonfly 4 3D printer up close and personal. And the working table is pretty small in comparison to some circuit boards that we deal with. I mean, it can't do something like the size of a sheet of paper. It's got to be smaller than that. But it prints 1 micron it can do one layer at a time on the board, a micron thick at a time. I mean, it's just crazy, the resolution, the size that it goes down to. And it can print, like, it can embed components within the circuit board itself. Like, it can eliminate the need for vias. It can do all kinds of stuff. So I know, Sean, you've talked before about questioning the durability of products like that compared to like a standard FR4 board. But they're definitely getting more and more advanced with the technologies they're using to do this with. And I mean, I think they're starting to be able to do like flex circuits with it now even. And that InScript down in Florida, I think, is another company that has some pretty awesome technology printing the silk screens and circuits right on top, like is conductive stuff right on top of flexible substrates and all kinds of wild stuff. So seeing the combination of technologies where in a pretty small footprint you can go through the entire fabrication and assembly process and iterate through different prototypes really fast. If we were like just a solid prototype house, there's a lot of expanding technology out there that really would allow you to step up the game and kind of take it forward. So that'd be my answer to the question.
Is that printing solder mask?
Can. Yep.
How about the finish on it? Would it be able to
Yep.
print gold?
Yeah, and the thing about it, when it's printing silver and gold and stuff, it somehow has a way of doing it with zero waste, I guess. Like I don't know how, but it extremely effective because I don't know. We use we do some thick film stuff, and the paste that you have to use, silver conductive paste and dielectric paste and stuff. I mean, that stuff is many hundreds or thousands of dollars for tiny little, tiny little tubs of it. So you can imagine how expensive it would be if the machine was messing up and just spraying too much silver out into the air or whatever. Like, that's not happening. It's super precise, and I don't know enough about it to be able to explain fully how it can do it without wasting anything, but they've got this down to a science, literally. So it's pretty cool. Okay, that was good for the listener submitted questions. Now we can move into our next segment, our Best of LinkedIn. This time we have a submission from Sean. His submission comes from Richard Vanderblom. So go ahead, Sean. What you got?
Yeah, this post is a little old when I first made this recommendation, but actually my phone just now updated to get this post. I can only see it previously on the computer, but now my phone actually shows it as well. And it was about the LinkedIn's new activity tracker, and it's a clear push to try to engage people more using their contributions, because it tells you how many comments you made, how many posts you made, and how many contributions you've made. And there was a time in my life where I really wanted one of those top voice badges on LinkedIn. So I did every day, blah, 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 and they never gave it to me. So I gave up after about a week. But,
So those
I
are
was
merit based then.
Yeah, sounds like.
I don't know. I was curious what your guys' thought is on the contribution thing. And to me, it's kind of annoying actually when I see it come up on my feed where I'm just like, oh, look at this guy or something.
So your best of submission is something that you find annoying?
Well, I'm sure I'm not the only one that finds it annoying. I know
So it's
I've
kind of a
heard,
worst of then.
well, I like his post because if you actually read his post, looking at YouTube, you can see in there he actually talks about how he doesn't like doing the contributions. And he believes that this is LinkedIn trying to push that propaganda, or I don't know what you want to call it, agenda, and having people do it more often.
Okay, so the contributions is literally only the articles. Is that what you're saying? Like, it's
And now, you know how you get that thing, it'll pop up, it'll say, you're one of the few experts that has been
right.
selected to answer, and I guess what annoys me about him, it's like, you're one of the few experts that has been selected to opine on the proper cooking of ground beef patties. Like, they never seem to relate to what I actually do, you know? Did you have that experience, John?
Yeah, mine was always consulting, and I've never done consulting in my life, And then,
Even if they're on point with what I do, I still look at, like, I was doing it for a little while, but then I saw somebody who kind of shed some light on what you're doing for them. I mean, it you're training their learning language model for them, like you're training their platform on how to uh try to advertise on their platform more effectively and stuff. I mean, they're using they're using our desire to network and collaborate and give our opinion just to harvest information for their AI. So I can understand why, if that's how it's being used, why people aren't like super enthusiastic about it. I actually kind of loved, you guys both know Tony Kelbert and follow him, and he earned a top voice from just
This
from
complete parody.
totally spamming those, those contributions. Like, they were such funny satirical answers, and everybody started picking up on it. And so his funny answers would get a lot of like insightful reactions or whatever on it, and so it would drive up his engagement on those, and it earned him. And the thing was, he was fully transparent about his attempts. He's like, "This is what I'm going to do. I'm going to use this style to see if I can earn a top voice badge," and it totally worked. So it shows you how meaningful they really are, I guess, would be my takeaway from that. Good contribution there, Sean, even though we gave you a hard time. That's good stuff. Okay, and now we have Elias's choice for best of LinkedIn. What did you choose for this week's selection, Elias?
All right, I chose a post by Chris C. with West Air Gases. I'm not sure anybody will think this is cool as I do, but it's a post about telemetry devices on gases, right? So we use oxygen as the assist gas in our laser cutting process. And once upon a time, we really had to closely monitor how much oxygen supply we had, because without oxygen, if that tank goes to hard zero, you're lying down. So it's kind of something that we had to monitor continually and really be on top of. And then came these telemetry devices, and it mounts onto the tank. It has a wireless signal, and it monitors the tank volume. And once it gets past a agreed upon trigger point, it sends a message to your supplier, and the next morning the truck rolls up and you're back in supply. So it's kind of one of those little things that you don't really appreciate too much until you remember when you didn't have one. But telemetry in our assist oxygen supply has been one of those deals that I really appreciate.
See, when I hear telemetry, all I think of is when I used to play video games, like once upon a time before having kids. And I'd play this racing simulation game, Forza Motorsport, and you could turn on the telemetry and see all the information while you were driving. And so we would find a long straightaway and go the wrong way down the circuit so that we would meet head on at full speed with oncoming traffic, and then watch the telemetry replay and see how many G's we'd be pulling at the moment of impact and stuff, and learned a lot of cool things about physics doing that. But I guess that's a slightly different application. More similar to what you're talking about for our selective solder machine. That's where I would see a similar application. We have our nitrogen tanks, and that's critical because you don't want any oxygen present at your selective soldering nozzle. So you actually have to keep a steady flow of nitrogen to keep the parts per million of your oxygen down. I think I know you see a substantial difference from every percentage point when you go from 99.995% all the way up to each one, 0.995 to 0.996, even going from 99.998 to 0.999, you see really substantial difference in quality at your wave there too. So you can't really afford to get too lax or lenient on your monitoring of your nitrogen to your selective solder. Our oxygen, our only application for that is a monster compressor that feeds the whole factory. So what about you, Sean?
PCB manufacturing, you had something similar, but for your deionized water stations, when your cation, cation, or your carbon need to be replaced, the new version would literally send a signal out to Evoqua. They would come in and replace the tanks. And, it went from you just had a scheduled maintenance to all of a sudden they put an LED light on there. And then all of a sudden the LED light spoke to the actual company of when to replace it. And extended tank life too. That was the nice part of it. If you didn't use it as much, they weren't there as much. And then when you did need it to be replaced, they came.
Just one less thing to worry about, right?
Yeah, for sure. And you don't want the same thing in PCB manufacturing. You want deionized water. You don't want city water in there at all.
Okay, another good submission, Elias. So my submission for the best of LinkedIn came from Brenna Moore, who is a heavy equipment operator, and she ran this pretty cool program called Build Her 2024, and it was like this immersive class where she was teaching women and young women, young girls, I think even, how to run excavators and different type of heavy equipment. And I watched some of the videos from it. It was pretty cool because you could see people who started out, super nervous and just not ready, not confident. And she was able to build them up, inspire them, talk them through it, and get them to perform different exercises with the heavy equipment. And so that was pretty cool to see her empowering some people that didn't think they had it in them. And then you saw what they could accomplish with a little bit of belief, and where that having somebody else who believed in them first, where that took them. So that was my best of LinkedIn.
I mean, LinkedIn really exposes you to the powerhouse of women that kind of get underappreciated. In fact, it was funny. I had a sales rep in the other day, and we were talking about. I was thinking about making a poll about, can we just end the debate now that just women are better solderers than men? It's just. I don't know about you, Daniel, but my shop is at 80% women. It has to be, and it's just, like you said, they get confidence, and then they turn out to be one of your best employees. It's very cool.
Yeah, all of our best solders had no experience when they started. No one has any experience when they started, but I mean, when they started here, they, had never soldered before they started here. And the ones that have all excelled, that they came here with no experience and have turned into like really quality solderers, that it's impressive how well they've taken to it and the quality of the product they turn out now. I mean, you'd assume that they have many years under their belts, not just like one or two maybe. Elias, you're quiet. You don't hire women, is that?
Oh man,
Yeah,
I was quiet because this just felt incredibly dangerous.
Yeah. Okay, so that will wrap up Rev 1.7. Thank you everyone for joining us, and we are excited to join you again next week. Hopefully we will see you there. So until next time.